Okay, number 6 should have been F. Does anybody need number 6? All right, number 7 should have gotten D as in dog. We need to go over that one?
Yes.
Yes? Shh. So you distribute, and you'll get 2x plus 8 equals 5x minus 7. Subtract the 2, and that will give you 8 equals 3x minus 7. Add the 7, and that will give you 15 equals 3x. Divide by 3, and that gives you 5. All right, number 8, you should have gotten H. Go ahead, Will. All right, does anybody need number 8? Anybody need number 8? Okay. Number 9, you should have gotten B as in boy. Come on, you should have gotten that one. That's what we just did a couple of days ago.
Yep.
Does anybody need number 9, though?
Nope.
You sure? Okay. All right, number 10, you should have gotten H on number 10. Does anybody need me to go over number 10? Number 10, anybody need number 10? Somebody said I do? No? Okay. All right, here's what we're going to do, ladies and gentlemen. We are going to finish up our graphing stuff today, which is on page 11. Then we're going to do one more lesson on Friday. We're going to review on Monday and Tuesday, and Wednesday will be the last test of third quarter. Last test of third quarter. And then Thursday we will start trigonometry, which is we're going to start with the real easy stuff from geometry, the right triangle, trig, sine, cosine, and tangent. And then Friday, y'all do not have school on Friday. You do not have school on Friday. All right, so grab page 11 real quick. If you don't have a calculator, a graphing calculator, you need to go get one. If you don't have a highlighter or a colored pencil, you need to either ask somebody to borrow one or come see me because I got a couple extra ones. All right, page 11. We did page 10 yesterday, and we're going to do the exact same thing on page 11 today. Okay, so here we go. Number 5. In order to graph this, what 3 things do you have to find or check for first? The holes, vertical asymptotes, horizontal asymptotes. Very nice job, Sydney. So what do you notice about the numerator and the denominator? You can factor them as x plus 1, x minus 1 on the top, and x plus 2, x minus 2 on the bottom.
Wait, sorry, I'm guessing I did that before yesterday.
We did. Okay, so in order to have a hole, things have to cancel out. Does anything cancel out here? No, so we don't have holes. So no holes on graph. Okay, what about vertical? Vertical's easy, okay? To have a vertical asymptote, you have to check to see where the denominator equals 0. So what would make x plus 2 equal to 0? Minus the 2, so x would be negative 2, right? So there's a vertical asymptote at x equals negative 2. What about x minus 2? What would make that equal to 0? Positive 2. And so you've got at positive and negative 2. So now you take your highlighter, and to review from yesterday, how do you draw a vertical asymptote? Dotted line, because it's invisible. We just draw it to make sure that we don't make our graph go past positive 2 and negative 2. All right. Horizontal ones are the ones you have to remember from the other day. There was 3 rules about horizontal, and they had to do about your exponents. So let's look at our exponents to start with. If you have the exact same exponent on top and bottom, you divide the leading coefficients. What's the leading coefficient here? 1. What's the leading coefficient here? What's 1 divided by 1? 1. So, you have a horizontal asymptote at y equals positive 1. Y'all okay so far? Alright, now we take our handy dandy calc. What? So that way you can actually see it. If you do it in pencil, it's really hard for you to see it showed up. If you have like a pen, you can do it in a pen. Okay, so we have parentheses x squared subtract 1 on the numerator divided by parentheses x squared subtract 4 on the denominator. Make sure you have it typed in correctly and then hit graph. Alright, you see it riding right along y equals 1 right here. Okay, so let's look at our graph. You see how it doesn't go below y equals 1? Do y'all see that? Do you see how there's like an invisible line right here that these run along at -2 and at +2? Alright, so let's go to our table. We can check a few things. What can we check? Huh? Should be errors where? At -2 and +2 where you have a vertical asymptote, right? Unfortunately, your calculator will not let you check horizontal asymptotes right now, okay? If you had a hole, you would be able to check that as well. It would also have an error where there was a hole, but we don't have any. Okay, so do we have any decent numbers that we can graph? -4, 0. Oh, -1, 0. And +1, 0, right? Those are two good ones. Alright, so what's happening on the graph there? Let's take graph and look at it. What's happening right there at -1, 0 and +1, 0? That's where it's curving back down, right? So it goes through those 2 points and it curves back down. We're just going to sketch those, okay? Because those decimals were like crazy hot messes. Okay, do we have any other decent decimals? I mean, you could do -3 and 1.6 if you wanted to, but the rest of them are like 1.1429, 1.038. Those are horrible. Okay, so let's just sketch the rest of it, okay? So this one is going to ride right along this vertical asymptote. It's going to curve down, but it's not going to go below y equals 1. Matthew D, are y'all okay on that so far? Okay. All right, the other one's going to do the exact same thing. It's going to ride right along +2. It's going to curve down, but it's not going to go below y equals +1. And that's it. Y'all okay? Okay, let me see which one has a hole. Oh, the next one has a hole.
We don't have to do exactly correct on.
If there are, when you go to your table and there are good decimals like 1.5 or 7.5 or whole numbers like these two, then those better be on there. But the rest of them, this over here and this over here had crazy decimals, so I'm not worried about that, okay? The main thing, Matthew, that I'm looking at is this stuff right here. And that you can put that on your graph. That's the main thing I'm looking for. All right, let's do number 6 together, and then y'all will do 7 and 8. Here we go. First thing we got to do is factor to see if anything cancels. So do you see anything that can factor?
The X on the bottom.
The X on the bottom. Very good. And they cancel. If they cancel, that's a hole. So we have a hole at X equals 0. Very good. All right, so what do we have left? We have 1 over x minus 6 left. So our vertical asymptote, when they cancel out, anything divided by itself is 1. So our vertical asymptote is what makes the denominator equal 0. What would make x minus 6 equal 0? Positive 6. Okay, your horizontal asymptote, you have to look back at the beginning, okay? We had another rule about horizontal asymptotes that said if the biggest degree is on the bottom, so the bigger, so you have a 1 on top and you have a 2 on the bottom. 2 is bigger. What happens when you have a y equals 0? Very good. Which is the same as what? The x-axis. Very good. Was that Madison? Very good job, Madison. So we have horizontal at y equals 0. We have a vertical at x equals 6. Let's talk about our hole, okay? I don't think I explained this as best as I should yesterday. So let's go over this again, okay? You ready? You have a hole somewhere where x equals 0, right? Somewhere. You don't know that y coordinate. So somewhere along x equals 0, right here, there's going to be a hole somewhere. I just don't know where it is yet. We got to graph it and see where that hole is going to be, okay? So let's go to our calculator.
Will it be wherever the line hits the x-axis? Is that where the
Yes,
hole will
yes, because the x, not the x-axis, the y-axis,
Yeah.
because it's x equals 0, which would be a vertical line. So wherever that line hits right here, Sydney, you couldn't have said that better, then it's going to be a hole right there. All right, so let's see. We have x divided by x squared minus 6x. Make sure that bottom's in parentheses. Guys, make sure you're practicing how to plug this in your calculator, okay? Because if you can't plug it in right, you can't get the answer right. Yes, ma'am.
I don't know if this is okay, but on my calculator it shows where the asymptote is.
Yes, some of the older ones have a setting like that, and that's perfectly okay.
Okay.
Yeah, like right here on this one, it's got a physical line right here.
Yeah.
Yeah, and then maybe at the top and bottom, it's kind of like all smooshed together, and you can't really tell which one's which.
Yeah.
Yeah, that's, well, like that one is an older one, so all the lines are black. So when they all merge together, you can't tell which one's which. This one's a color calculator, so if I were to put my asymptote in, you would distinctly be able to see which one was which because they're color coordinated. So that's the only reason why it disappears at the top and bottom. So. All right, here we go. Let's go to our table and see if we have any good things. First of all, let's check. What happens at x equals 0? It's an error, because that's where your hole is, right? Let's see. What about at positive 6? What happens there? An error, because you had a vertical asymptote, okay? Do we have any good decimals? 5, negative 1. 1, 2, 3, 4, 5, negative 1. Mackie, were you saying that negative 0.5? No? Yeah, 4, negative 0.5. Which one? I can't hear you. Is there another one after that? Oh, yeah, there is. 1, 2, 3, 4, 5, 6, 7, positive 1. Right there. All right, that looks like about it. Okay, so here we go. You ready, Sydney? All right, so let me zoom this in a little bit, especially for those people that weren't here yesterday. Do you see right there at 0 how it kind of has like a little smudge? You can't really tell that it's a hole, but it's a hole. It kind of jumps over. Can y'all see it? Did I make it big enough? Yeah. Okay, that's where your hole is going to be. So when you draw it on your paper, it's going to be very, very, very difficult to make sure that your hole is not on your asymptote. So do the best you can to draw your hole right there, okay? Yes, sir.
Mine just stops. Yeah, mine just stops. The line just stops.
It doesn't keep going?
Nope.
That's weird. Let me see what you're talking about.
Yeah, that's what mine does.
No, baby, that's because it's not color coordinated. So that's what I was telling Madison. Your calculator is not color coordinated, so you can't tell where this line begins and your asymptote begins, like your x-axis begins. Because it's riding right along this x-axis, right? Which is a big, thick black line. So you can't tell which one begins. So your calculator just smushes it all together. It doesn't really stop. It just looks like it does. Does that make sense? So if yours is color coordinated, like mine is color coordinated, then you're actually going to see this get on the x-axis. Does that make sense? Are y'all okay with that? All right. So, all right, 7 and 8. Y'all try those two real quick. And then what we're going to do the rest of the class period is several of us have checkpoints that need to be turned in. And a couple of us have a few problems on our test we have to finish. And sophomores, there's still a few of you, I think, that I haven't signed off on your registration packet. So make sure I get those today as well, okay?
checked on like all of them off.
Yeah.
You didn't take it. You
I checked all of them, but I didn't take it?
Yeah.
That's weird. Yeah, I want that. But we'll do it. We'll do it. Brinkley put up number 7, so check your work with number 7 with hers and make sure you got the same thing.